This is the self-contained chess computer that you've seen in the previous video that uses stockfish and senses moves using reed switches underneath these squares, switches on LEDs to indicate moves, and has a playing strength in excess of 2,300. This computer is based on Raspberry Pi plus an Arduino and various other components. So let's turn it over and have a look at those components in more detail. So here we can clearly see the components of the chess computer. First of all, over here in the corner is the Raspberry Pi. The Raspberry Pi runs the Stockfish chess engine and a few other Python programs, but the board is controlled entirely by the Arduino, and the Arduino over here communicates with the Raspberry Pi through this USB interface. The other connections on the Raspberry Pi are an Ethernet out, an audio and a video out in case we need it, and that's really about it. Another USB out that just goes to a blank USB plug. So the Arduino over here, which in this case is an Arduino Uno, controls all the other components on the board. The two main components are for the two matrices, the LED matrix and the reed switch matrix. The LEDs are used to flash the movement of a square when the computer is making or receiving a move. So over here we have an LED controller which is connected to a XY matrix of the LEDs, an 8x8 matrix, by these two wires, one on the X and one of the Y matrix, and you can see here one of the LEDs that's connected. So this is a chess square, and this LED here has two connections, one to the X-axis, one to the Y-axis. The LED controller is then connected itself directly to the Arduino. The other major component is the matrix of reed switches. Here's a reed switch here. Now, because the game obviously includes pieces on many squares, some reed switches will be on and some will be off. So therefore we need to actually be able to tell which specific reed switch is on or off. The way I have chosen to do this is by a direct connection. So this is what's called a centipede board and has 64 direct connections to the reed switches. The reed switch has the connection at one end and then the other end goes into a common earth. The centipede board is connected straight to the Arduino Uno. Now, because this centipede board also includes pull-up resistors, the logic for sensing and operating the reed switches is really very straightforward. There's lots of other ways of dealing with matrices, and I'll be discussing those in another video. The other components of the board are 4 simple push buttons here, which are used for the user to signal things like level and so forth. And then over here an LCD display where messages are portrayed. Apart from that, and a buzzer that's buried somewhere in here, that's it.